we have the last part, this one. Oxidizing, reducing agent, the super confusing one, or is it not confusing to you?
It's a bit confusing.
So oxidizing agent is a substance that causes another substance to oxidize.
Yeah, okay.
So you remember it like that, oxidize cause others to oxidize. Yeah, oxidizing agent. So oxidizing agent, because it causes others to oxidize, right? It itself is reduced.
Okay.
Then reducing agent is it causes other substance to reduce. So a summary will be like this. If something oxidizes, it is a reducing agent.
Okay. So if the substance that causes other
Oxidizing agents cause
so
other.
so it's the opposite lah. Right.
Yes. Oxidizing agent reduces itself. Reducing agent oxidizes itself. Okay.
Yeah.
Then we have this example. Down here, we are supposed to identify the oxidizing agent and the reducing agent. So we explore this zinc and zinc chloride.
The zinc is plus, so it's oxidized.
So oxidized.
So it's the reducing agent.
Yep.
And then the hydrogen is the oxidizing agent.
So HCl is the oxidizing agent.
Okay.
Because this is, so HCl is the oxidizing agent. You copy the whole thing, you are not going to just isolate hydrogen.
Okay.
So they say, who is the oxidizing agent? HCl. Who is the reducing agent? Zinc.
Oh, so you must state the whole thing. Okay.
State the whole thing. You don't go and just write hydrogen in HCl is the oxidizing agent. You don't do that. They will just give you one type smack and then you fly and then your mark's gone.
Okay.
These are the common oxidizing and reducing agents. Have an impression, but you most likely only need this.
Potassium manganese.
Yeah, maybe one of this from iron. A lot of them is just there, you just have an impression. Hydrogen peroxide is also a reducing agent here. But then not in syllabus lah.
So it's both?
Hydrogen peroxide is a reducing agent and an oxidizing agent.
Oh, okay.
Yeah, so it depends on what you add. If you add acid or a base to it. But not in syllabus lah, don't care. No need to know.
Okay.
Okay, so we want to test for oxidizing agent. So if you want to test for oxidizing agent, we will use a reducing agent. So we add potassium iodide. Potassium iodide is a colorless solution.
Okay.
Yes. So then if you drop a few drops of oxidizing agents into it, the solution will turn from colorless to brown. If there is this color change, then that means an oxidizing agent is present.
So if the solution turns brown, substance is oxidizing agent.
Yes.
In either one.
That means what happened is like this. You have Ki, then you have unknown substance X, and you want to know whether X is an oxidizing agent or reducing agent. So you throw X inside. Originally it's colorless. If after you throw X inside, it becomes brown, then you conclude that X is an oxidizing agent.
Okay.
If you throw in and nothing happened, then X is not an oxidizing agent.
In either solution.
When Ki is in a Ki solution. Yeah. So your X is usually a solution also. Seldom, unless they throw in some other thing which is unknown to me at this point of time. Okay. Then the second one, right, is add equals iron 2 iron solution or something. So that means it's just iron 2 solution. So it could be a sulfate, it could be nitrate. Yeah, whatever. So the solution, if it turns brown, that means this thing is actually green color. If this green color solution turns brown, then it's an oxidizing agent.
Okay, so you must remember the
color change.
Okay.
Most common is this one.
Okay. Then the bottom one is only for iron. Is it?
It's also it's also a test for oxidizing agent. So you just drop a drop of oxidizing agent inside, then the green solution will turn brown.
Okay.
So same goes, if no change, then it's not an oxidizing agent. Then if you want to test for reducing agent, you use this two, potassium dichromate or potassium manganate. So dichromate is orange. If you throw in something which is a reducing agent, dichromate will turn green. So then if you want to use potassium manganate, then you will turn from purple to colorless.
Okay.
Very drastic color change. So the takeaway here is, if you want to test for oxidizing agent, you use a reducing agent.
Okay.
Then you want to test for reducing agent, you use an oxidizing agent. Just use the opposites.
Okay. Which substance undergoes oxidization? Gain oxygen. Magnesium, right?
Yep. Then explain your answer.
Magnesium. Why explain using the oxidation.
Also can use Use whichever. Oxidation number also can, because now down here, right, the question does not restrict you to whichever definition to use.
So I can say that magnesium gains oxygen,
to become magnesium oxide, so it is an oxidation process. And therefore magnesium is oxidized.
Okay. Undergoes reduction. The lead loses oxygen, therefore
lead oxide loses oxygen to become lead.
Lead oxide loses oxygen to form lead. Therefore it's oxidized, right?
Huh?
Therefore it's oxidized.
Lead oxide to lead.
It's reduced, sorry.
So they are basically asking you for whether magnesium is an oxidizing agent or reducing agent.
It is a reducing agent as it has been oxidized.
And cause lead oxide to reduce.
Cause lead oxide to reduce. It is the oxidizing agent as
causes magnesium to be oxidized into magnesium oxide, and it is reduced to lead.
Okay, so you must say it causes,
because the definition of oxidizing agent is it's a substance that causes another substance to oxidize while itself being reduced.
Okay.
So I have to bring out these 2 points. Magnesium is a reducing agent because it causes lead oxide to reduce to lead, and itself is oxidized to magnesium oxide.
Yeah.
So that's why I made that statement, because I want to follow the definition.
Okay.
Identify the oxidizing agent.
Identify oxidizing agent. This one just identify, I don't need to explain.
Don't need, question did not ask you to explain.
Copper oxide.
Because it's lost oxygen, right? Then
the reducing agent is NH3, right?
Yeah. So if it's on the reactant side, if there are only 2 reactants, one will be oxidizing agent, the other one will be reducing agent.
Yeah.
If it's on the reactant side, 2 only, right? If one is oxidizing, naturally the other one become reducing agent. So it become ammonia.
Yeah.
This question is an asshole.
Explain in terms of electron transfer. NH3 undergoes oxidization reduction. Yeah, how to explain in electron transfer again?
So you have to examine whether ammonia lose or gain electrons. So nitrogen has. So nitrogen here is 5.
Yeah. Yes.
Is it? No, this is -3.
Yeah, -3 because hydrogen is plus.
So then it becomes like that. So in order to become this, it will have to power 0 here. So that means it will lose electrons. Yeah. Then it lose electrons. You want to figure out how much it lose. 6?
6. How do you know how many electrons they lose? It's the 3.
So down here, this 3 minus.
Yeah.
So 3 minus, that means it has excess of 3 electrons.
Yeah.
Then because of the 2 in front, then that means there is an excess of 6 electrons.
Yeah.
Yeah. Then nitrogen gas alone, it has no excess, so it's 0.
Yeah, you must still get the 6 minus, so you must get
the 6 electrons must be balanced off, so that's why the 6 electrons is here. Or if you want to do math, then this is 3 minus, and 2 of them, so 6. So -6 here. So then here is 0 charge. Then your left hand side, right hand side, the charges must balance. So you must introduce 6 negatives. So this is
okay.
So that means it oxidizes because it loses electrons.
Okay. When a person exhales into the catalyzer, any ethanol is converted to ethanoic acid according to the following. Ethanoic acid is the weak one, right? It's a weak.
Yes, it's a weak acid.
It's reduced. Which statement about the reaction is correct?
Don't think too much.
I mean, the oxygen gains hydrogen, right? And then ethanol is oxidized to form ethanoic.
So read whatever I wrote. Ethanol plus oxygen gives you ethanoic acid plus water.
Okay.
Answer is there, right?
Yeah, ethanol is oxidized to form ethanoic acid. C, right? Is it C?
Yeah, ethanol is not reduced.
Yeah.
Because it will take in hydrogen. Then ethanol is an oxidizing agent. I think it's oxidized, so it's a reducing agent. Then ethanoic acid is on the product side. So oxidizing and reducing agent is only on the reactant side. So D naturally goes off.